YouTube afterwards, so just for warning to everybody, fair warning that this is being recorded. So if you missed something, want to go back, I just got a habit of recording these things and putting them up. I'll tweet a link afterwards. This talk is getting started with Photon, subtitled Blinking Lights for Fun. If you were here in the session before, you got to see soldering and all kinds of cool things. This is going to take a step back and I got this in the mail, now what? So we're going to start off with the basic things that frustrated me getting started because I didn't read directions. So I'm going to share that with you in this time, and we're going to integrate it and do some fun stuff. To start off with, just who I am, Chris Johnson. You can find me most places as Johnson CH on the internet. My name isn't John, even though a lot of people mistake me that for my Twitter handle, but I'm also the dev manager at a company called Roche Review that does medical education software. So if you're studying for emergency medicine boards or your physician's assistants, different exams, come get question banks from us. There's a few ground rules to set everybody on the stage here. A little disclaimer with this talk, right? This is all based on my personal experience. Like anything, your mileage may vary. The reason I'm doing this talk is I thought it was something cool. I haven't made anything that's production ready, so I haven't dealt with any of the security issues or deploying these out or anything like that or producing them at a mass scale. This is all just tinkering on my kitchen table, which I think is fun to do too. So there are probably folks in the audience that know more about some of this stuff, electrical engineering and things like that. Please join in the discussion. Let's have a discussion and share ideas. The whole reason we're here is to learn from each other. It's a community event, so we'll bring that into a micro community focused here in the room. If you have questions, please ask them. However, if you want to argue about something, buy me a beer later, okay? We're not going to argue about it in here. I'm sharing my experience. And I'll try my best to answer any questions. If you know how to answer a question, please chime in. So why am I giving this talk, right? Go back to my slide. It's because I was interested in this, and I got this kit for Christmas, and I got frustrated a little bit working with it. Like, there's got to be other people that are having these same issues too. I know, I'll do a code camp talk. One, that'll force me to use the thing I got for Christmas after it's been sitting on the shelf for a while. And two, that way I can share those frustrations and hopefully you all don't have those as well. We're going to start with a few definitions. The Internet of Things, IoT, haha, what? It's supposed to be a joke. Come on. I know it's the end of the day, but this is my dad jokes, bad humor. I have 3 of my students up here that are used to this on a weekly basis, so they can attest to the quality of the content. The Internet of Things, right? It's just hooking stuff up to the Internet. This is the long Wikipedia definition of it. We're going to hook up some blinking lights to the Internet. What are we going to use? We're going to use a Photon. And the Photon is a microprocessor made for prototyping things from a company called Particle. It's this little thing in the middle of the breadboard here, this little tiny chip. The Wi-Fi version is $19, and the cellular version, the Electron, is $69. So it was Particle. They're a company that has built a platform for managing these devices and interacting with them. They have their own domain-specific language in JavaScript. They take away a lot of the issues you might run into trying to push code to it. I've never gotten into the Arduino thing, but coming from a heavy web development background and no electrical engineering, I was able to hook stuff up and figure it out after a little trial and error and get things to work. So it's pretty cool because it takes down the barrier for a lot of folks to get into making something, right? Not like when I was a kid and I would just take apart everything I could get my hands on. I'm sure many of you are in that same boat, like, oh, this works, but I'm going to take it apart. Now it doesn't work. Mom's mad because I broke the vacuum cleaner. But the whole idea is they have taken that, the complexity and stripped it down. So it's not, I got to find all these parts and hook them up all together. They give you a nice platform for it. Here's some links to where you can get the stuff, right? You can buy it directly from Particle. You can now get it on Amazon. These slides are Markdown deck, and they'll be up on, it's up on GitHub, and I'll have a link at the end so you can get to them. And then there's a book that I bought that was kind of helpful in looking up stuff. I usually don't buy paper books. I love trees. I don't want to come down. I usually don't buy paper books, but this one struck me as useful in getting the diagrams in there for wiring stuff up because I have no background in electrical engineering. So today we're going to code something up. We're going to talk about getting started, but we're going to code. What are we going to build today? Well, at the end, we're going to build a light that is controlled by a Travis CI build. So we have a little Rails app that has two branches, one that passes and one that fails. And when it passes, it turns the green light on. When it fails, it turns the red light on. So you can hook it up and set it at your desk and watch when your build changes status. Getting started with this stuff. Well, what do you need first? You got to buy some hardware. You can't simulate it, to my knowledge, so you need to go buy some hardware. I bought or got for Christmas the Maker Kit, which includes a whole bunch of stuff. I really don't have any idea what it all is, but it comes with all kinds of blinky lights and stuff. If you want to check it out, I have it up here afterwards. You also need to create a Particle account for the easy hookup at particle.io, and then you'll need the smartphone app to configure it and get it on the Wi-Fi. So let's play with that, and the first thing we can do with it is called Tinker Mode. So when you get the Particle, you take it out of the box and put it on a breadboard or something, and then you plug it into a USB outlet. And it'll start booting up. It'll start flashing, and it's going to pre-connect, but I'm going to show you how to reconnect it to Wi-Fi. It'll flash, and you need to hold down the setup button. And it's kind of hard to show. And then it starts blinking a different color. Figuring out where that button was took me a little bit of time. And then you need the smartphone app. So I have my IoT folder here. And it shows up right now. We're going to add a new one, go through the simulation of that. So I'm going to click on add a device. It's going to ask me what kind. The Photon is the Wi-Fi one, and the Electron is the cellular that has the SIM card with it. So we're going to do a Photon. Now, the thing I got overexcited about was on this screen. I had like jumped the gun and was like, oh, I'll just connect to the Wi-Fi before even opening this app, because this broadcasts its own little Wi-Fi network to connect to. And I couldn't figure out why the thing was just spinning and hanging out there. You have to power it on and have your phone connected to some internet source when you're at this screen, and then you hit ready and follow the directions. So if you're impatient like I am, it's hard. You got to read and pay attention to it. So once it connects up, we can go ahead and connect to that Wi-Fi network. And of course, I don't have that spelled out.
So you use Android? Or
yeah, there's an Android version too. Yeah, so you just need the smartphone app. And then there's a Photon network that shows up. That's just unsecure. And then it tells you, hey, it's connected, so you can hop back over.
Quick question.
Yep.
If there were 5 photons in the room, they'll all have different addresses.
Mm-hmm. There's it shows on the screen a little bit, well, it'll probably jump quick, but it shows that that there's a unique 4-digit code. I don't know how they determine the uniqueness between them, but this one has always showed up at that. I don't know if there's like there might be even a marking on it, but it's so small that. And then it lets you pick the Wi-Fi network you want it to connect to. They are pretty resilient, and they seem to connect back up again after you unplug them and plug them back in. But you do need to get them connected to a network. The one that's been paying is plugging into the event Wi-Fi or the free one here. So I'm going to connect to my hotspot just so that I can. And everybody will probably connect to my hotspot and drain my data. The 2 gigs on there, you want to keep onto the presentation. Need it. And it'll go through and configure itself. And those of you that are front kind of see it's actually connected and flashing and doing something. The light's blinking, so that's a good thing, right? Then it gives it a name. They're all cute and funny. We'll just leave it as Power Ferret. And that's how you actually go through. What I did there was you re-add the device to switch Wi-Fi networks when you're moving around from place to place. That took me a while to figure out too. And then the first thing you can do is right away get some, as it was discussed in the earlier talk, getting the light to blink is half the battle, right? So we're going to make it blink. And there is one LED on the board that you can blink right away, and it's under D7. So we can have it, we'll turn it on. So we got the second little light on there. All right, we got a light. Okay, so we know everything is kind of working there. And we can hop back over to my slides. And just in case network connectivity was not working, there are the steps for it, or if you go back later, to try it out. So now we can actually put some little LEDs on there and blink those with the smartphone app as well. Now, in this picture up here, it shows what I'm gonna connect up. I do not have an electrical engineering degree. I didn't understand the resistor and that it's color coded to go a specific way the first time, and I couldn't figure out why the lights weren't blinking. I'm like, I plugged it in. There's like 4 wires. Then when I looked closer at it, it was like 11 o'clock at night when I first did it. Closer, like, oh, hey, there's a color combination, a pattern they go on. It's because I didn't read and pay attention. I was too excited to just start plugging stuff in. So let's see if I can do that right now here. It's not going to be a cool live soldering demo, but very precise measurements here. I will say the breadboard is a pretty cool thing for this prototyping stuff and figuring things out, because you can just stick stuff together and they get connected for you. So if I have this wired up right now, we have red LED on pin 0 and then the green LED on pin 1. So I'm going to hop back over to, as you can see, the phone. I'm going to turn it 0 onto a digital write, and then I'm going to turn 1 onto digital write. So that will send power to it, is what I understand. So let's try the red one. We have a red light and a green light. All right.
Thanks for coming.
Yep. Right. Okay. So that's what we're going to trigger to do, and that's kind of cool. And so you could just sit and watch your build, and when it passes, hold up your phone quick and turn the color on for your teammates. But that's just not really scalable. So we're going to go to the cloud, and we're going to trigger them from there. This is where we get to some live coding. We're going to use Particles Online editor for ease in their cloud. We talked about last session, it got brought up in discussion that you can host your own version of their cloud if you want to, like, constrain everything into your network and are very security conscious. But we're not going to be that much, and me, for the things I'm playing with, I really don't care either. So let's hop over to the cloud editor here, and we're going to I'm kind of clunky here, but we're going to use a one of their pre-built apps. So they have, first one we're going to do is with Blink and LED. They have some sample stuff to get you started. Then you fill out their heavily commented code. I have it more condensed here. We'll just pull it up and we'll walk through this quickly. It's a little small up here. We'll start off by creating variables for each of our pins that we're going to use. We're going to use the 0 pin, which is our red, and then D7, which is the onboard LED that can be lit up. So we're going to initialize variable for them. In the setup, we're going to tell that the pin mode is using those, and it's going to be an output so that it can send to it. And then the loop, we're just going to loop through, and we're going to turn them on, delay, turn them off. So it's just going to blink the red and the onboard light. But when you get started on it, one of the things that I skipped over that and I found really helpful later was I read the comments that they had in here. You can see there's a lot of stuff. It explained what was going on in a lot more detail, and let me build my own app after that. The one nice thing about their online editor, right, is they have a way to check your code. I want to use this example. So you can click verify, and it's going to compile it and make sure it works, and then you send it down to your device. Now I only have one device here. If you have multiple devices, you want to pick the one. Now it hasn't completely updated to know that it's got the same ID, but it has a new name from reflashing it. But Dr. Tasty was one of them that came up. When I was setting up for the first time, I probably spent a half an hour sitting there thinking of this grand naming schema for all my evil plans with these things. And I never got very far, so I started calling it like Particle 1. Which was a terrible, yeah. So now, after flashing it, it's looping and blinking lights. More blinking lights. There was a video in case the internet didn't work. So now we can profit, right? We can blink a light, ship it, we're done. We want to build something we can control with a remote request. So we're going to end up creating a new app, and we'll make it Travis CI Blink. And then I have a pre-built file with code in there for the red and green, and we'll flash it to our Photon. So the kind of same process we just went through, and then keep iterating from there.
Question?
Yeah.
So I've seen in both this example and last presentation was that it's mostly an output, but is there like a sensing capability where you can sense, some numerical information from?
There is an example on their stuff that is reading with a photoresistor, and then in this book there's one, and the kit comes with a temperature sensor, I think.
And light,
And I think there's a photoresistor sensor in here,
okay.
and I think there's a vibration one too. One of the projects that excited me about doing, but I haven't done yet, is attaching the vibration sensor to the washer and dryer, and having, after it stops, text that the washer or dryer is done, because laziness, right?
How about gyroscope orientation? Do they have anything like orientation like your cell phone has?
Just probably, I don't know.
You're not able to hook up any kind of sensor because basically all you're doing is you have digital I/O
Yeah.
or analog I/O, and you're just, as long as you're measuring voltage or an on-off state, you can pretty much hook any sensor up you want.
There's even a little
They
action.
make a particle internet button, which is the Photon plus an LED ring, and then some accelerometer and stuff, all in one little package.
Yeah, there's endless possibilities with it.
Yes.
All right, so let's take a look at this code, and I'll just put it up in the browser here. So I'm just going to open up an existing project called Travis CI Blink. So here I've renamed the, and can everybody read the code, or should I make it, try and make it bigger? It's back, it's okay?
I can see just fine.
So this is that first line, the system mode automatic. I read that that will like keep it connected to the internet, to Wi-Fi. I don't know much else about it, but that's the default mode, and somebody told me to put it in, some blog post said put it in there at the top of every file, so I left it in there. I have the two variables for red and green. I named them so that I would know which one is which, and I could go back, and I think I did that right. 0 is red and 1 is green, yep. And then this one is a little different. Last one we just looped through and triggered turning them on or turning them off. This one is going to set up and create a function, and that function allows us to hit it with an API. So we'll be able to make a request over the web to trigger it, not with our smartphone flipping it on and off. But it's going to set up that the pins are set for output, so that we're going to digital write, and then we're going to create a function called toggle, LED toggle, which takes in a string, and so you can see here it's using a statement, or if else, to that's red, turn on the red, turn down the green. And then we're gonna, since we're setting it up, we're gonna set them both off when we first flash the device, so that it's not like one light left on in an on state and take a trigger before it gets back to it. It doesn't, the function needs to return something. That's the way their DSL is set up. I had to return 1 for success for and 0, that there's really no reason behind it. It's just returning something. And then I could see that I was triggering the right one from the API response. And if it doesn't hit one of those, if somebody just puts another color, it'll return -1 to it. So let's flash this over to our device. And it'll stop blinking up here. Wave my hands over it. All right. So now it's set up to work with this. And one of the cool things is you still get from the there's in the inspector on the phone, you can still play with it before writing an API call and just see if you kind of figured stuff out right. So we had 2 arguments with ours. It could be, or 2 options, red or green. So if we type in red, and hit send, it turned it red. And if we do green, it should turn it green. So the thing I liked about this is it took me a while to find it, and I was struggling with, I don't really want to write a whole client and figure out all the API parameters and stuff. I want to make sure that I can just do a quick test and make sure I got my code somewhat set up. There's no simulator or anything else to verify that's working. So having the phone there was kind of nice because I could have my code, okay, try it out. You can also do it from the web and the device console here. See, it named it Who's Your Chicken before. Crazy names. So when you open it up, then it gives you that same interface to switch it back and forth on the device. So you can really get a good sense of, did I get this stuff? You can also, I haven't tried the reading sensors at all. I've just sent to it, but I understand you can make the call to it and get data from it. But on to the next part, which is using the API. So, right, we're software developers. We want to control it with our own code and not have to still go use somebody else's device to do it. So they offer a very simple API interface that breaks down into needing your device ID and your access token, and then the name of the function you want to trigger, and then a generic args parameter that gets passed into it. This is a screenshot. Mine because I keep forgetting where to look for these things. But in the web console, you get your devices, you can get the device ID, and then from settings, you get your access token. I blurred them out even though they're going to be in the rest of it because I didn't think that through, and I'm going to have to go reset mine after this talk since it's being recorded for the internet. But you'll need both of those. And then you can make a curl request to it or use some other programming language. My basic example today is we're just going to use a couple curl requests to make a call to the device. This is an example of one to turn it red, and then we have another one for turning it green. And let's see those work. So this is the success one, which is a green coded. We'll look at it in a second, but and oh, need to export the keys first. So turn to green, yay! And we could do a failure and turn it red. Constantly going backwards, so improving our experience as we go along here. All right, so we have all the pieces we need. We can turn it programmatically on or off, or red or green, but now we want to have some automated fashion. So in this example I wanted to build, I wanted to use Travis CI because it was a simple way to build something and have a status of the green or red. So we're going to use an example that I set up on Travis, and it's going to use this Travis configuration. Now this is a Rails project. It really doesn't matter. The important parts are there's two scripts down here. One is for after success and one is for after failure. Now this won't work for parallelized builds. It's very much broken down for a very simple one process build. And those scripts look like this. So that first example we showed, this is the two of them, and I ran them. So we have failure, and all it does is takes arg red, the success takes arg green. So the strings that we're passing through to it. And arg is the one parameter it can take, and that's the default that they called. As far as I understand, that is how you pass something into your function. You can pass multiple values to it, but it's one parameter. So let's check that out. So I have two branches here. I have master and I have master and then one with a broken test. So right now it's, let's just reset this back. And we'll push our branch up. And we can go out here and watch our build run. This is exciting stuff. It's like watching progress bars off the screen and watching your build run. Nope. It's all in the excitement. The anticipation is building. Is it going to pass or is it going to fail? When you're preparing for the talk and you run it and you go do something else, what's in the background, you don't pay attention to this portion of it.
Question.
Yeah.
It looked like the device ID and the access token maybe flashed by in the log, but it was just said secure.
Yep.
How does it know what to?
Yeah, so
hide?
that's a point that I was jumping into. So in this case, right, so my access token is now blasted in the samples that I've showed in here, right? But in a real world situation, you want to obfuscate it as much as possible or hide it. Travis, one of its services is you can set environment variables. So in the script, it was using environment variables of access token and device ID. I've gone ahead and set those out there so that they're secure from everybody. However, if you do dig into this code, and it'd be different, I had committed them originally into the curl examples, and I'm like, wait, that's not very smart. So that's what just a configuration of Travis. Now, if you're running on your own build server or something, it really wouldn't matter if your code base is private, but it's a good call out. So the build ran, and it's red. Our LED is red up here. Success. And we can go push the master one and push that up and let it run, and it should turn green on us. While that's going, the issues that I ran into, and the reason for me wanting to do this, one, I kind of talked about my lack of experience with electronics. I have a soldering iron to pull out with this stuff, but I have not taken it out of the package because I'm afraid to do something permanent. So the breadboard is truly a wonderful thing for prototyping and figuring this stuff out. Not something you want to send off into production that way. Reading directions, right? So that was one of the things that I kept skipping over. Like, I can figure this out. This can't be that hard, right? It's just some JavaScript. Read the directions, pay attention to what's going on. If you understand electrical engineering, you probably have an easier time than I did, but if you're coming from the web world like me, you got to pay attention to that stuff. The other hard part about this was the setup and tear down time, right? So I was doing this on the kitchen table at night after kids were in bed, and drag out this kit of stuff and start looking for the project plans, laying it out, figuring out what I need, writing the code. By the time you get going on it, you're getting half hour into it, and all of a sudden it's getting late. Like, okay, I got to tear it down because I don't want to leave it out on the table and let the 3-year-old find all the stuff and scatter it everywhere. Or the 11-month-old find a resistor hanging on the floor. That happened. That wasn't good when I picked up stuff. But that is something that was very frustrating for me. It took a little bit of like building something to get really excited about it, but the first time I was like, okay, what is all this stuff? Trying to figure it out and pull out the parts without really knowing what's going on. And that's where I found that this book was helpful in some projects because it actually has wiring diagrams in there and explains what's going on rather than just plug these things into these spots and voila, you can blink a light over the internet. Those are the things that I really ran into that I would like to save someone else some time on. And that's it. This code is up on GitHub. Kind of went through really fast. Thought there'd be more questions than that, but yeah.
Sure. So, what is obviously you get these tiny little things that kind of hard to see even in the back of the room. What kind of power usage can you get out of that? Could you light like let's say an LED type bulb?
No, I think it's max of 5 volts left or 4.8
Well,
volts.
it's 5 volts, but only an amp.
Yeah.
It's only got 1 amp.
It's
Really using the Apple style.
It's got supposedly 1 amp. That's where my lack of electrical engineering comes into.
Usually,
basically the Apple
usually a
adapter.
microcontroller board is about 40 milliamps.
Oh, I'm sorry, I don't misunderstand your question. As far as driving LEDs out of the VIN pin on that, it's an amp. But I guess I don't know about
The rest.
Yeah, you're going to want, if you're going to drive anything high powered, you're going to want to put a transistor on the circuit and use that to drive it. Basically, most microcontroller boards are really low output, but transistors are basically switches, and they can handle more power.
Is that easy to do on that?
It would be pretty easy. Or a relay, if you want to do 110 or high AC voltage, you can buy
Sorry,
relay
about like
boards.
an LED bulb.
Yeah. Well, LED bulbs are 110 volts, so you're going to want a relay in the circuit, otherwise you'll just smoke your board.
Yeah.
You're powering this to a USB. What is the, if you're going to use batteries, how much power does it need to run?
You know, I don't know. It came with a little battery kit that I didn't open up. Let's see how many batteries it holds. So it's
That looks like
probably,
a 4 AA battery.
Yeah, it looks like.
I can't get it open. So probably 4. But this is the battery pack that it came with.
What was the book that you have there?
It's the Getting Started with Photon. It's linked in the beginning of the slide deck. So if you grab the slides from there. Yeah.
So I'll save you from electrical engineering questions. So what you were doing here was very much a web push, which from the security point of things, I guess it opens you up to the audience being able to control you, so get your access token.
Yep.
But is there a way to do the reverse where instead of making your device an endpoint, make it a client that then polls?
Yep.
Which would not be as nice to Travis per se, but.
I haven't set that up, but they show in here you can create in an integration. You can create a webhook
Wow.
to which then your device pushes to the particle platform, and then the particle platform. When you set this up, I was just reading about it. I haven't tried it. So you have an event that publishes, and then this is the URL to your app. So say in the washing machine example, I just make a Twilio call or something to track that. So that's.
But you can't do like a straight curl or something like that from that board directly. You're
I haven't.
pushing to there. Yeah, effectively.
I haven't tried to see what JavaScript libraries are all available on there. Do you know? Yeah, that's this is the basics of it, but yeah, I haven't tried any of that push out. But that would be the interesting thing for like temperature sensor monitors. You know, the cellular ones, being able to put them in a remote place and monitor temperature, humidity, and send out.
Is there a set up meetup here in the city at all for Photon?
I don't know. I'm from Madison, Wisconsin area, so.
There's the IoT Fuse, which is like the Arduino MN, which is like the open hardware meetup group. Well, they merged with IoT Fuse, so you're gonna want to look for IoT Fuse on meetup.com. And they're kind of like now all like open hardware Internet of Things. Both you're gonna want to look at like each individual meetup. Some of them are more businessy, some of them are more makery, but.
There's another question. Yeah.
It looks like the DSL outputs an INO file, or that's the extension of the file.
Yeah.
You open that up or try to get access to it. Is that like C, C++ that it dumps? Or?
I haven't. Well, I could try and download it here. I think. Oh.
My guess is it's probably something.
Oh yeah, so it compiles it and downloads it. So it must be some. It's compiled. I just remember seeing the download link.
What's the maximum program size?
I have no idea with that. I haven't tried to push it anywhere. So this guy's limit. It compiles down. I don't know how well they compile it down with their stuff, but.
You run out of memory when the device itself, or you run out of memory for this. Does that make sense?
Anything else? Well, we'll wrap up a little early here, but thanks everybody for coming on up, and hope you have a